Welcome back to Thermal Energy with Daya. In the previous episode, we saw that thermal energy is connected to the microscopic motion and interaction of particles. Today, we will clear up one of the most common confusions in science. What is the difference between heat and temperature? People often use these words as if they meant the same thing. In physics, however, they describe different ideas. Understanding the difference helps us explain hot drinks, weather, engines, refrigeration, and the human body. Let us begin with heat. Heat is energy transferred from one system to another because there is a difference in temperature. It is energy in transit, not a material stored inside an object. For example, when you hold a hot cup of tea, the tea is at a higher temperature than your hand. Energy is transferred from the tea to your hand, and you experience that transfer as warming. The natural direction of heat transfer is from the warmer system toward the cooler system. If the two systems remain in contact, their temperatures move toward one another. When they reach the same temperature, we say they are in thermal equilibrium, and there is no net heat transfer between them. Temperature is different. It describes the thermal state of a system and is related to the average kinetic energy of its particles. When the average microscopic motion is greater, the temperature is generally higher. When the average motion is lower, the temperature is generally lower. But particles do not all move at exactly the same speed. A temperature summarizes the average behavior of an enormous number of particles. A thermometer does not measure how much heat an object contains. It measures temperature, using a physical property that changes in a predictable way as the thermal state changes. Here is a simple analogy. Imagine two groups of people in a gym. In the first group, there were many people moving at a moderate speed. In the second group, there were only a few people, but they are moving very quickly. The average speed of the people is like temperature. It tells us about the typical motion of an individual person. The total motion of everyone in the gym is more like the total thermal energy of the system. It depends not only on how fast the particles move, but also on how many particles there are and how they interact. This is why a system can have a high temperature without having the greatest total thermal energy, or a lower temperature with a large amount of total thermal energy. Consider two containers of water. Suppose a small cup is at 80 degrees Celsius, while a much larger bucket is at 40 degrees Celsius. The cup has the higher temperature. Its water particles have higher average kinetic energy, but the bucket contains many more water molecules. Depending on the masses, heat capacities, and reference state, the bucket can have more total thermal energy, even though its temperature is lower. So remember the essential distinction. Temperature describes an average microscopic state. Heat is energy transferred because of a temperature difference. Thermal energy is the microscopic energy associated with the particles in a system. This difference matters when engineers design engines and air conditioners, when meteorologists study the atmosphere, and when doctors and biologists study the human body. In the next episode, we will explore how particles behave in solids, liquids, and gases.